Oi? Quando tiver tudo certo, me avisa, Léo, que aí eu inicio.
Beleza, beleza. Nós estamos ao vivo,
Certo?
tudo certo?
Bom, boa tarde a todos. Quero agradecer a todos pela presença aqui no nosso primeiro webinar do Namitec. Meu nome é Francine, eu sou pós-doc do Namitec, na parte de divulgação de conhecimento, né, divulgação científica. Eu sou formada em física, então estou iniciando agora esse pós-doc. Então, esses webinars que vão acontecer ao longo do ano também vão ser parte do meu trabalho, né, do meu trabalho de pesquisa. Após cada webinar, eu vou passar alguns questionários para poder avaliar é, a participação e tudo mais, para que depois isso se transforme em dados para publicações. Bom, quero apresentar aqui também o Leonardo, que está organizando esse webinar junto comigo. O Leonardo é aluno de iniciação científica também nessa área de divulgação científica, e junto comigo também organizando esse webinar temos o professor Ellison. E agora vou passar a palavra para o professor Diniz, que vai introduzir um pouco sobre o Namitec. Boa tarde, professor, e, por favor, pode compartilhar sua tela.
Boa tarde a todos. Tá correto aí o posicionamento da tela,
Certinho,
tá?
professor.
Então, é um prazer falar com vocês, mais um webinar. No ano passado a gente teve vários, esse é o primeiro, prazer, e o Instituto, eu quero falar um pouquinho sobre o Instituto Nacional de Ciência e Tecnologia, com o nome de Nano e Microeletrônica para Tecnologias Habilitadoras, com a sigla NAMITEC. Nosso, é um projeto que vai até 2027. Ele surgiu em 2001 como Instituto do Milênio por duas fases e depois, em 2009, se tornou o Instituto Nacional de Ciência e Tecnologia. E hoje nós estamos aqui em andamento com uma verba recebida de 2022 até 2027, com 6 milhões de reais e com 86 pesquisadores, 21 grupos, 17 instituições atuais. Então, como eu disse, nós temos 86 pesquisadores, é, com, é, é, partnerização de 40 no Brasil, 40 internacionais, o suporte técnico são 12, as instituições são 17 e as cooperações são de 46, e uma boa parte internacional, 26 as cooperações. Aqui a gente pode ver que os laboratórios, as universidades, eles estão distribuídos aqui em 3 regiões do Brasil, no Nordeste, no Sudeste e no Sul, né? Em São Paulo tem o CTI, a USP, a Unesp, a Unicamp, a FEI. No Rio Grande do Sul tem a URGS, tem a empresa TOT, a Unipampa, Unicinos, em Santa Catarina, no Nordeste o FRN, o FPBE, Federal da Paraíba, Federal de Sergipe, Federal da Bahia, o EN, Estadual de Maringá e a Federal do Paraná. E, além disso, também tem os colaboradores, né, do Maranhão, do Instituto Federais, e Federal de Viçosa e assim por diante, né. Aqui são as colaborações que nós temos no exterior. Então, temos desde de grandes institutos, que nem o IMEC na Bélgica, que nem o CEA-Leti na França, o Cine-University no México, a Cornell University nos Estados Unidos. São 36 colaborações no exterior, o que nos dá a caracterização de internacionalização do nosso projeto. E também nós temos colaborações com empresas, né, tipo a MK Photonics, a ST Microelectronics, a Chipos, né, que também caracteriza que o nosso projeto também está sendo apoiado pelas empresas com troca de tecnologias. Aqui são os objetivos baseados em aplicações de IoT, design de IP de circuitos integrados para IoT com várias aplicações, dispositivos eletrônicos avançados, sensores de fotônicos e dispositivos orgânicos e sistemas, materiais e módulos de processamento e packaging avançado de empacotamento para empacotar os dispositivos, sensores e circuitos. Então, aqui nós temos 8 atividades, né, baseada, como eu já disse, a 1 de IoT, a 2 de design, a 3 de dispositivos, a 4 de sensores, a 5 de parte de fotônica, a 6 a parte de materiais e micro e nanofabricação de processos, e a parte de empacotamento, package, e a 8ª na parte de divulgação científica do nosso projeto. E aí que eu queria enfatizar não só não só o programa Escola 4.0, o programa Maná, esses 2 programas eles conseguem chegar em escolas e até conseguir ter 6.000 estudantes fazendo parte desse programa, mas também temos a parte de ajuda às escolas de microeletrônica, o Seminatec, que é um evento que nós organizamos para estudantes no estado de São Paulo, e a webinar. Os webinars, eles estão aqui, né, para divulgar o nosso projeto. Então, essa área A8 ela é muito boa por causa da divulgação, além das publicações de patentes, os vídeos e a nossa mídia, né? Tá, toda a parte da rede social nossa. Então, o nosso projeto, só para finalizar, ele tem uma abrangência do Nordeste ao Sul, ele é amplo no espectro de materiais e aplicações. Ele tem aderência aos objetivos do programa INCT, por causa das várias especificações dele. A gente está ampliando parcerias, em especial com o Ceitec, que é uma fábrica de microeletrônica, de dispositivos e circuitos integrados. E o relatório, se vocês quiserem verificar, a gente está disponível na nossa rede, no nosso site. Obrigado, Francine. Passo a palavra de volta.
Muito obrigada, professor Diniz. Bom, a palestra de hoje ela foi indicada pela Área A1, então agora eu quero passar a palavra para o professor Ellison, que vai fazer uma breve introdução dessa área.
Muito obrigado, Francine. É, bom, antes disso, professor Rivo, Randria, thank you for your your time with us now. I will make some considerations in Portuguese, and after this, I will switch again to English to introduce your presentation, okay? Bom, essa área a primeira área, né, que indicou que indica nosso primeiro webinário, a área A1, que é a área de IoT e aplicações. Essa área é coordenada pelo professor Raimundo Freire, que nesse momento está acompanhando, está aqui nos assistindo, mas por questões aí de saúde familiar, ele está de sobreaviso, pode precisar sair a qualquer momento, então ele pediu que eu fizesse a introdução dessa palestra, desse webinário para ele, né? Para que a gente tenha apesar dele estar acompanhando com a gente, mas para que a gente não tenha interrupções aqui, que possa a nossa palestra percorrer tudo da melhor maneira possível, né? Essa palestra, essa área da IoT Aplicações, ela é uma área que é dividida em 6 sub-áreas, né? Em 6 subprojetos, que são atividades, na verdade, que estão dentro dessa área, com pesquisadores de vários locais aí do Brasil. A primeira atividade é a área de desenvolvimento de redes de sensores sem fio para aquisição, monitoramento e registro de grandezas físicas ambientais, que é coordenada essa atividade pelo próprio professor Raimundo Freire, da UFCG. As atividades 2 e 3, que é a parte de desenvolvimento de IoT para monitoramento remoto de áreas florestais e aterros sanitários, auxiliados por drones e nanosatélites, e a atividade desenvolvimento de LEDs emissores de UV distante, de 220 nanômetros, para aplicações em saúde, são coordenadas pelo professor Cleonilson Protásio, da UFPB, da Paraíba. É, a atividade 4, coordenada pelo professor Fernando Rangel, trata da transferência de energia sem fio, de energia sem fios e aplicações biomédicas, que é o Fernando Rangel da Federal de Santa Catarina. A atividade 5, uma arquitetura inteligente para elementos de IoT aplicada para o desenvolvimento de aplicações urbanas e não urbanas, coordenada pela professora Lenier Ailon, da UEM. E, por último, a última atividade é a inteligência artificial aplicada a sistemas de comunicação sem fio com alta eficiência energética. E o responsável por essa área é o professor Eduardo Gonçalves de Lima, da UFPR. Então, a área 1, que é IoT e aplicações, é uma área bastante diversa que cuida aí desde a parte de, que tem projetos importantes aí, desde a parte de rede de sensores sem fio, com alta eficiência, em ambientes urbanos e não urbanos, como florestas, aterros sanitários, sendo enquadrados nesses estudos, mas também passando por transferência de energia sem fio e monitoramento de incêndios em florestas e várias aplicações. Então, é uma área bastante diversa que tem como o centro da sua área o IoT, a internet das coisas e a rede de sensores sem fio, e os projetos têm mostrado que a gente tem tido resultados bastante interessantes em todas essas atividades que têm sido apresentadas, né? Hoje, tendo um propósito de aumentar a nossa possibilidade de cooperação, de conhecer pesquisadores dessa área, de trazer novas cooperações, o professor Raimundo Freire convidou, então, o professor Rivo Randriatsiferana para fazer uma apresentação sobre a IoT e a gente conhecer um pouco mais sobre essa área. Now I will switch again to English and then I wish to take again to Professor Rivo. I don't know if my pronunciation is correct. Andrea Rivo Randriatsiferana. Professor Rivo holds a PhD in Networks and Telecommunications at the University of La Réunion, French, in 2014, and the engineering degree in Industrial Computer Science and Electronics at the University of Antsiranana, Madagascar, in 2009. He has had several international research positions and contributed to IoT and the RED projects, particularly at the development of smart devices and the interoperable protocols. From 2021 to 2024, he has an assistant professor at the University of Rennes and a researcher at the IETR and IETR. He is currently a tenure track junior research director at the IRD with the Space Dev Unit at the University of Guyana at French. Currently, his research focuses on low power wireless networks, intelligent architectures and protocols, as well as the application of NGD circuits and the tensor-based analysis from smart object systems in water, biomass and the energy domains. Thank you, Professor Rivo. It's a big pleasure to us receive your presentation here at our webinar. And we have 30 minutes for your presentation, and after this, we have time for questions from the Zoom audience and the YouTube audience. Okay, thank you very much. Feel free for make your presentation. Your audio is closed. We are not hear you because your microphone is closed.
Do you hear me?
Okay, okay, here.
Okay, thank
Thank you,
you.
Professor.
Okay. Today, my talk is about of IoT LP1 in the Amazon. So I would like to you how application and challenge for environmental monitoring in your side. So my talk follow this motivation. So why IoT in Amazon? So Amazonia cover nearly 6.7 million kilometers square. It provides 10% global carbon sink and vivid biodiversity hotspot. However, there are current threats to this region which include the reforestation, climate change, and illegal activity. To monitor the Amazonian environment, survey systems are used such as satellite for remote sensing. For example, in Guyana, sea station is used. And I saw now they have produced a detailed program in Brazil. So this method is primarily detect change that are already while under Y and for limited temporal spatial resolutions. There is need for fine quasi-real-time data isolated areas with limited energy and neural network infrastructure. There is the role of IoT LP1 network. So LP1 low power wide area network designed for the long range and low power communication IoT applications. The term LP1 cover wide range of technology such as NB-IoT LTM or LoRaWAN, Sigfox, Amazon Sidewalk. There is new technology and standard actuality OSN and MIoT. So then in your application, we can privilege from private network and only subscribe the spectrum using LP1. Why? This is dependent on the cost infrastructure. So we privilege used standard and license code spectrum and private networks such as LoRaWAN, Son and MIoT, and so on. There are many technologies. So if you want to work in LP1 network for application monitoring, you should choose which technology you want to use because there are fragmentation technology. And that one depends on also application requirement. Our application is need autonomy or high data, or we need internet connection and security. And then which network topology our application needs require. So there is no silver bullet for LP1, but LP1 selection comes down ecosystem, dependent application, which network, and more other factors. Let's say there are many applications actually in the world, like IT automation, infrastructures, agriculture, and rainforest, for example. Where our main area of interest is the Amazonian, so we focused in rainforest. Rainforest, some work done about of water quality, biomass monitoring, estuary surveying, remote microclimate, dams and energy monitoring, wildlife and deforestation application. Donc, there are some work done in the literature from 27 till 2025. The first application is the water quality monitoring of Peruvian Amazon. Their contribution is they develop pH and UC temperature local nodes and deploy this in your Kakadu River. There another work proposed monitoring system in illegal forestation in the Amazon rainforest using AI algorithm. So they used LoRa technology. Now there are a big platform in Amazonia called Rainforest Connection. They used GSM satellite nodes to monitor the biodiversity and use acoustic sensor for Guyana acoustic platform. There are also a multi-species evolution digital wealth monitoring with Sigfox across habitat in 2030. They try also used Sigfox and try to compare which application is good for GPS or GSM or Sigfox. And he used for Jaguar and Jaguar tracking monitoring. The latest work is about of hardware and protocol development to tracking board on Amazon River with LoRa and LoRaWAN. So what's work actually on the canopy? So there is some scientific result about of propagation model in Amazon River, near Belém. They saw that the delivery data rate is more than 16% at 11 km river path. Some work try to propose a new algorithm for parameter selection to reduce time and delay and for energy consumption reduction. Some work attempt to analysis of performance. Again, it will use LoRa technology. They say the delivery rate is more than 7-8% at 1.5 km. This work is done with Service River Amazonas. And so one work you see a multi-species evolution for digital red monitoring. So use Sigfox, that's work is kind of tracking 1 to 25 animals and 30 species. to my knowledge, actually, no more study about of NBOT and Sigfox technology under forest canopy. So the standard topology of LP1 is include end device, gateway, network server, and application server. The topology is start topology between end device and gateway, and gateway and TCP protocol between gateway and server. And server need internet connection. However, there are some constraints due to denser infrastructure such as telecom network, connection with deeper forest region, example by here is example by Orange in Guyana, which is mainly accessible in peripheral city area. But it is important to survey an inaccessible area of rainforest where there is no internet connection and have multipath interference. So, if end device communication between end device and gateway is star topology, that means one hop communication. When device communicate directly to the gateway, we have a connectivity and a coverage gaps. Donc, first proposition, how to reduce connectivity and how to improve coverage gap. We need a miniature autonomous end device design. So, because we need to deploy they there in an accessible area, so the autonomous end device needs have an energy resource completely, donc higher autonomous. If end device and gateway, when end device communication between end device and gateway not accessible for one hop, we need mesh network topology. There is one challenge. Why? Because LP1 is natively star topology. Donc, why? However, we need to do how integrate mesh technology in this standard. One second proposition is consider one wave mobility relay to cover connectivity and coverage limitation. So mobile relay such as drone or balloon can optimize dynamic coverage in addition of miniature and mesh topology. Donc, actually, I'd like to talk about our research that needs also, it's also an opportunities for collaboration for Parisian institution. Donc, development, our work is about the development of intrinsically autonomous and sustainable IoT network. Our focus on two main axes, IoT device architecture and activity, and network architecture and interoperable communication protocols. We focus on IoT device miniatures and use multi-resource energy. How the device should be also frugal and sustainable. In other ways, we focused on mesh networking and mobility also. So to mitigate IP addressing issues, we use IPv6. That we need also energy efficient routing and how to manage the data traffic. About of IoT device architecture and device. So our goal is how to maximize energy harvesting efficiency and thus develop subjects to minimize losses and manage energy allocations. So that's combined of design of frugal and sustainable architectures. When device in sleep mode, it must attempt to harvest energy. And on the other hand, in this case, we need to manage a lot of asynchronous communication and synchronous communication. It's noticed that the LP1 IoT standard don't consider asynchronous communication. This is also an open challenge of research directions. So in this exercise, we focus on intelligent management of energy allocations and how manage channel access in the network. Second axis about mesh network and mobile station management. So it is the research direction is why, how LoRa work in mesh topology and how consider mobile when we use mobile relay. That's also need cross-layer adaptation protocols for IPv6 or the LoRa mesh. And because we used in inaccessible areas, we need energy efficient routing protocols. So just on primary work, actually, we focused on energy evaluation of some AI and edge machine learning survey. Donc, here I try to do comparison with by using on-bound confidence bound algorithm machine learning based with LoRaWAN standard protocols. So the goal is here, which in the area in the rainforest, which to try to find the optimal channel we can use to transmit our data with a higher data rate. As we said here, actually, research work only attempt more than 76% data rate. So in this work, we attempt to 85%. So why I cannot actually show the results here, because it is under review. So I can just show my result in these discussions. About this result, we can see here the proposal SCB algorithm. Now, first figures. this is now used USB, and the second phase used UCB. So we can see here the UCB is not consumer energy, is less energy consumption. In our work, result is 3% of global consumption of IoT actually. So to go further in this research, we actually ask about the use of drone or balloon relay and satellite to LP1 hybrid communication, which we ask also which electronic domains by using ambient energy IC. We ask also which the device end of life, how to monitor its degradation in reality in the canopy, forest canopy. Donc, for conclusion, LP1 is scaled for true in-situ monitoring, where satellite links reach their limits. LP1 are not perfect or complete solution to a problem, but they address a significant and important need. Deployments are still fragmented. There is clear need to unit project and research community. For Amazonian research, monitoring, multi-village collaboration spanning engineer, ecology, and social science are needed. Thank you. My discussion is
Thank you, Professor Rivo. I will pass the word for Leonardo to conduct the questions. Eu gostaria de incentivar as pessoas, a nossa audiência, tanto aqui quanto no YouTube, a fazer perguntas, e se alguém não se sentir confortável a fazer perguntas em inglês, por favor, podem fazer em português mesmo, e a gente ajuda aqui na tradução para que a gente possa sair daqui o mais esclarecido possível, né? Bom, thank you, Professor Rivo. Leonardo, pode ficar à vontade.
Okay, hi, Professor. Can you hear me? I'm just waiting to see if anyone posts some questions here in YouTube.
okay.
Okay, if no one has any questions, I do have one. Can you go back and slide, I think it's 15? The one where you showed two graphs.
Yes. This one?
Yeah, exactly. What kind of device? It's the 2 and 3. I couldn't make it.
Ah, okay. One is TTN gateway.
Okay.
The two is STM32. The three devices analog power fail device. Device.
Okay, I see. Yeah, thank you.
Professor, I have one question too. I want to know, can you explain a little more about what are the biggest technical challenges to ensure connectivity in such remote areas?
if I understand your question, why connectivity?
The biggest challenges to ensure connectivity in these areas.
Okay. Donc, the big challenges were here a problem is just a remote here. Okay. So in Guyana, we have no internet coverage. Okay. So we want to monitor water and mangrove situations in remote area. We try to find which solution could be help us. So we try to do that. Our problem is now the end device, the distance between end device and gateways, 50 kilometers. Because the gateway needs to connect with TCP, so our device needs to communicate to do multi-path communications. Okay. So for that, for multi-path communications, we have another challenge. What we have a addressing problem protocols, how to address network in this case, and how to manage protocol to do in routine protocol with in the mesh network. That is also a challenge. Another ways, because we want to use the technology because with LP1 we are ESM band limitation. We can in our application we can transmit 100 message per day. That is our limitation. So we need to use a short communication technology like MyOT. So MyOT used IPv6. And we want to use LP1 for a long distance communications. So we need also to do interoperability to cover our system. So for this reason, we try to find to resolve connectivity gap and coverage gap in this case.
Okay, thank you, Professor.
I have one question too. Professor, thank you for your presentation. You show to us the possibility to make a mobility of nodes to increase the connection. Okay. So to ensure the mobility of the network nodes, we usually need to know the location of the nodes, the localization, the location. But in the forest, the rainforest, like the Amazon forest, the GPS signal is often lost due the tree canopy. How to deal with this, the loss of the GPS signal and the need to know the location of the nodes? In case of the mobility of the nodes.
No, actually, now we can have tackled about of localization of nodes because we know just in the when we said nodes, I talk about end device. Okay.
Okay.
It's because why? Because each end device communicate directly with mobile relay, and in the mobile relay, you have energy is not. We consider energy is not a problem because in this because we are comment ça s'appelle ça? Just let's say that. Okay. Donc, in mobility relay, we don't use energies consider no problem. So, donc, with relay, we can use GPS. And CPA, with each network have identifications. So we can say, in this case, the network identification, which network, which site we have monitoring actually. So localization is not our first problems in this case, because we know our site and we know, and in this we know because in our protocol we say which network we can interact in this problem.
Okay, thank you very much.
Okay,
Just
so we have another question from people in YouTube. So Cleonicio Protásio, he says, we are conducting a research to get long-range communication using LoRa, sending packages directly to satellites. He asks, do you think LoRa is a good communication way to do that?
I don't understand.
I mean, he's talking about using LoRa. I don't know what it is, but it's spelled like L-O-R-A.
Yes.
So do you think this LoRa thing is a good communication way to do that? Sending packages?
LoRa is good communication, he said?
Yeah, he's basically asking if it's a good
if it is good or not.
Yeah.
Okay. Actually, yes, by compare with Sigfox and other protocol, another technology, actually LoRa consider a better technology. So for this reason, much more of work focused on LoRa protocol, LoRa technology, but LoRa protocol. That's it.
Okay. Oh, thank you.
But just we have a problem in the canopy in river. Just we have now more just 17% of data delivery rate. That is not sufficient in your case, in your canopy. So that's indeed that is a challenge to improve that.
I don't think we have any other questions from people at YouTube who are watching us.
I don't think so. We have. I don't think we have another questions.
Mas obrigado aí ao Cleonício Protásio por perguntar.
Bom, já que nós não temos mais perguntas, eu gostaria de agradecer novamente ao professor Rivo pela palestra. So I would like to thank you, Professor Rivo, for the seminar. So, eu gostaria de convidar todos para o próximo webinar do Namitec. Então, nós ainda não temos o tema, mas assim que tivermos, nós iremos divulgar nas redes sociais, no LinkedIn, no site do Namitec. Então, quero convidar todos que estão aqui, tanto no Zoom quanto no YouTube, para o próximo webinar. Gostaria de agradecer novamente a todos que estiveram presentes aqui, ao professor Rivo e aos professores aqui presentes. Muito obrigada a todos.
The guys at YouTube, they're also thanking you, Professor Rivo, for being with us today. Thank you very much.
I'm sorry for English because I am very, very tired. We'll try
Sorry,
to do
I just said that the guys in YouTube who are watching us live, they're thanking you. They're saying it was a very good presentation.
Stop.
Okay, that's it. Thank you, Professor.